Hello and welcome to this new episode of Linux Literacy. Today, tar. Where does it come from? How does it work? And what's its secret functions? Coming up. So yeah, today we are talking about tar. Now we all know and love tar, right? It's the start and the end of our project. We often start by taking an archive from somebody else and end up sending an archive for somebody else. So let's actually understand how it works and where it comes from. Let's start by that. Where does it actually comes from? Now, tar comes from the need to have a way to send data to a magnetic tape. Magnetic tape were a technology that started in the 1970s and that was there to store a big amount of data on a cheap medium. Now, magnetic tape themselves are cheap. Of course, the magnetic tape reader often very expensive, but the idea was that inside of a magnetic tape, you would often have the same capacity as the biggest hard drive of the time. So, because the magnetic tape was cheaper, if you were to write a lot of them for archival purposes, let's say, it would become way cheaper. Now the big issue with the tape is that it cannot really be searched around. Like on an hard drive, you would be able to go back to the start of the hard drive to look at your inodes or look at your superblock, and after that you would go see your files that are a little bit further on the drive and go around like that. That's not a possibility with a tape, because a tape is just a tape and two spinning wheels. So when you read around on your tape, it takes a lot of time to go from the start to the middle to the end to back to the start. So going around is not a possibility. So with those needs was created the tape archiver. Now the job of the tape archiver is to take a bunch of data, put it in a nice archive, and be able to stream it directly to your magnetic tape. Now, this will become very clear that tar was created for those purposes a little bit later on, because some secret function of tar really make that past very relevant. But tar in our modern world doesn't really relate to its past at all, because in our modern world, we use tar as an archive, and in reality, there's always been a bunch of choice for archive. You can archive using a zip, you can archive using a CPIO archive, but in the Linux world, tar won the archive battle, so we're left with tar as the standard that everybody use. Now that we know the past of tar, let's actually look at how it works. Now, just so you understand the little playground that I've made, we have a file named A, a file named B, one named C, and then a directory named D containing a file named E. So with all of that, we will be able to play around and kind of understand the functions that are inside of tar. And let's start with the most standard command that we might see, which is the one to create a new archive. So tar-cvf 1.tar ABCD. So here what we see is we of course call the tar command. We start with -c. Now C is for create, so we create a new archive. V is for verbose, which means that we will see some kind of feedback from tar, what files are being manipulated. And then we have F, which is for file, which we can specify what the name of the archive that we want to create is. So with that we can form a block, so we could do -c space -v space -f. That would work too, but in tar, the standard is that you will make a block with all of your options at the start. So that's why we do the CVF, and we need to end with F because F actually needs an argument. It needs the name of the archive. So that's why we do it that way. Of course, now that we've executed that command, we have created an archive containing A, B, C, D, and what is inside of D, which is E. Now, with that, let's just take a look at our archive. Let's take a look inside to see what's going on. For that, we would need the option T. Now, let's do tar-tf 1.tar. T stands for list, so we can list the content of the archive, and here we see the content of the archive. Now, if we were to want to, let's say, decompress or extract this archive, well, it would be extract because technically it's not compressed. So if we want to extract our archive, let's just create a new directory. Let's call it result. Let's move our archive inside of result. Let's enter a result and let's extract our one.tar archive. So what we do is tar-xvf1.tar. Now X is for extract, so with that we can extract our archive, and we can now see that we have exactly the same content inside of our directory. Now that we've covered the very basic, let's go one step further. Tar can actually give us a bunch more information when we extract or when we do anything with it. We can actually call verbose a second time, and with that it will tell Tar that we want even more detail about what's being touched when we are extracting or compressing our files. With that it will tell us the permissions on our given file. So that way we will have a little bit more detail about what's going on. So that's always useful. Now that we know about double verbose, let's just get out of our result directory and let's delete that. Now we can see that we have our clean directory, and let's create a new archive. But this time, let's put the name tar.gz instead of just tar. Now by default, tar is configured to actually recognize what compression algorithm you want depending on the name that you give it. So if you do tar.gz, it will compress it using gzip. If you do .xz, it will compress it using xz. So whatever extension that you use, it will kind of guess what is the right compression algorithm for it. Now, if you're using a non-standard extension, you can always force tar to actually put the compression that you want. There's a list of extension that you can use, but in general, if you change your extension like that, just make sure that you include -- the type of compression that you want to use, and use the same standard command that you would always do. Now let's remove our archive and let's actually create two archives. Let's create one.tar and two.tar containing half of our directory each. Now one thing that is very fun with tar is that we can actually fuse archive together because, well, it's been made for that, right? We want to make it as easy as possible to be able to fuse things together because we are thinking in terms of tapes. If we were to take one tape and a second tape and we would want to put both of them onto one final tape, or even on the same second tape, we would be able to do it. So for that, we will use the -A command. With that, it will actually take the second archive, so two.tar, and it will glue it to the end of one.tar. So with that, if we look at the content of one.tar, we have the full content of our directory. That's of course because we've just glued the two.tar to the end of one.tar. Now there's way more that we can do than just gluing things around, right? We can check for differences between what we have inside of our archive and the actual directory that we're in. So if we do, for example, tar-d, we can use that function to compare what is inside of our archive and what's inside of our directory. With that, we know that, well, there's no difference right now. Of course, we haven't modified anything. So let's just modify something to try to make it do something. So let's modify C, let's add a 5 at the end, and let's run tar-df1.tar again, where we will see that it will tell us that, well, the time at which it has been modified has changed and the size has changed. So with that, we know that there's been some change in the C file. Now let's say that we would want to actually put that change onto the archive. Now there's a bunch of ways that we can actually do this, but let's just glue the file to the end of the archive. To do that, we use -rf. Now -r just glues whatever file you give it to the end of the archive. It does nothing more. So if we look at the archive once again, we will see that C is at the end, but it's also at the middle. Actually, that's because tar will only look at the last version of our file when it will be decompressed. So we will only have the last version unless we specify that we would want a prior version, so we can actually update or put more information that way. Now, when we're looking at that command, it makes a lot of sense if we think about it in tape form, because, well, tapes, we cannot really go in the middle of the tape and remove some data and then put the end of the data at the end of the tape. Not all tape are rewritable first, and even if they are, well, it's really a clumsy way to copy data, and we want to be efficient in the way that we copy our data. So that's why it will just glue it at the end of our archive. Now let's actually try to delete the C of our archive. That's possible. We just tell --delete and then what we want to delete from it. So if we look at the content, now all the C's are gone because we have decided to delete C. Now there is also another way to update the files that you have inside of your archive. So let's just create a new archive by removing the old one. Let's create the new one and let's change B, for example. Now what we can do is we can do -uvf. Now -u will update the archive. It will also tell us what changed in the meanwhile. So it's kind of a fusion of -r and -d. So it will take whatever change and add it to the end of the archive. So with that, we know that, of course, B changed, and we can see that it has been glued to the end of our archive. So that's pretty much all there is to it. You know everything there needs to be known about tar. So of course there's a bunch of small things that you could know more, but that's the basic, right? Just know that those more complex commands like -r or -u or even I think -d won't work on a compressed archive. So you need to decompress your archive before using those commands because it won't be able to actually apply those commands and it will just fail. So I hope you enjoyed this video. If you want to see those videos a little bit earlier than everybody else, think about getting yourself a YouTube membership to Maple Circuit. And if you want to see all the great sources of this video, you can go on maplecircuit.dev where they are all listed. Now this is all from me. I hope you enjoyed, and of course, take care.